I was recently sent this picture, and the person asked how they could make this print better. And we're going to discuss that now. I'm Tom Meeks with the Youth Quest Foundation, and this is a tutorial in how to optimize your prints. Let's zoom in on this picture. The first thing that we see is that as the print came up, this stem was very narrow. Because it was narrow, it began to wobble. When it began to wobble, it started losing adhesion. And so there's this area right here where it lost layer adhesion and failed to come straight on up. Then, as it got to the bowl of the goblet here, it was pretty wide. So there were some flat areas that were unsupported. This let filament drop down, which stuck to the nozzle, and then eventually it came off over here in a big glob. Well, as it moved up, all of this weight was hanging on this poorly supported stem. And as the print head went back and forth across the object, it moved it. So we see these kinds of anomalies here where X and Y are pushed over slightly and offset. So how can we make this a better print? Let me hide this. Okay, well, let's show a frame that would be typical of a goblet like that. This frame would be revolved to create a goblet. And as you can see, we come up, we have a stem here, and that stem's fairly narrow. But the real problem occurs right in this area. Remember, we print in layers. So I'm going to simulate those layers right now, right here. There we go. And if you can see the layers, each 0.20 millimeter, is a layer. And that layer reaches over to the edge of the design. Now, in actual fact, the layers are a series of cylindrical motion by the filament. And if we did a cross section of that filament, we would see this. All right. Now, this would be the cross sections of the filament as they go around and around and around to make the items. This is what we would hope to see right here. As each one gets wider, it's supported by the filament underneath. But in reality, here's what happens. The filament underneath, let me close that and I'll show you this, is unsupported in certain areas. Notice how when it reaches over to the design point here, a lot of the filament is going to be hanging over. It's less so up here. So let's turn that back on again, and we can see that this piece of filament and that piece of filament are unsupported. And it should fit into this profile right here, but in actual fact, that filament droops. Notice how the filament is not supported, so it droops down. And because it droops, it creates that uneven surface that we saw on that cup and creates problems. Let me close this down now. I'm going to look at another design very similar to the first. Here we go. As you can see, let me get this in the picture here and make sure you can see it. As you can see, this is very similar to the blue frame, but the red frame does not go out horizontally in the same way that the blue frame does. It's more movement upward than the blue frame. This is going to give us better support. Also, because of the way we're going to print it, I've altered the way the base is designed with more slope in the base rather than this more abrupt slope right here. So let me turn off frame 1 and we'll go back to our layers and we'll see how that works. All right, we'll zoom in here. You notice now, because it's moving more at a more vertical than horizontal, it's sort of even as it moves across, that there is no large area of overhang. See this? This is not very large. It's about the same size as this. Therefore, if we showed our filaments here, you'd notice that all of the filament seems to have at least a portion of the filament supported by the robe underneath it. Now let's turn this into a 3D object there that follows our thing. You'll notice then, even if we printed this upright like we do now, there's more chance of it being able to work. First, this is wider. We made the stem wider. That's going to give it more chance to be solid and rigid. Gives it added support. Then as we come up to here, it will not slope out so much as up. And so we'll have more chance for it to be supported. Each layer will be supported on the outside edges. But there's a better way to print this. As a matter of fact, what I would do is I would print this upside down. It's the same object. Now let me mention that you don't have to turn it upside down before you send it to the printer. All slicers that I'm aware of enable you to turn an object over and reorient it for best printing practices. In this case, I suggest printing it upside down, even if you don't design it upside down. Notice that as we start, we've got a nice, wide, broad base. That gives us much more stability. Then as we move up, there's no overhanging. The only potential overhang would be on the inside, but this angle is such that the chance of some filament not being supported is minimalized. Then it's wide up here, and not a lot of weight is being put on this. Even as it goes up toward the base, we've changed that angle so that it's more this way rather than that way. So as it goes up, it should be well supported and finally finish the piece and look the best that it can possibly be. So my advice on objects like this is to check the orientation in which you print it to see if we can optimize the print based on changing that orientation. Hope this is helpful. Thanks.